Hello and welcome back to Norton live streams. I hope you're well. Okay, in case you didn't know, these live streams are part of a series of live streams we perform here at Norton. And in case you have missed any previous streams we've done, you can catch them all on our YouTube channel, which you can find on there. Lots and lots of different information about the abrasive products we produce. So, a really interesting channel for you to have a look at your leisure. Okay, so before we start, just a quick bit of help on this platform we're using, Microsoft Teams, which is called closed captions. So in case your English is not quite as good as it could be, you can click on the gear icon, follow the instructions on the screen here, and choose from a selection of available language to have subtitles at the bottom of your screen. Okay, so today's subject is how to choose the best cutting disc for the job. So yeah, as we all know, there are a huge variety of different cutting discs out there in the market, and the sizes and thicknesses are quite bewildering, to be honest with you. There's a huge amount of differences in the products, as we can see on the table here in a moment. But hopefully we'll try and get that a little bit clearer in your mind about which disc you should be using for the job you're doing today. Okay, so let's have a quick look at the agenda for the next 30 minutes. Okay, so first of all, we're going to introduce you to the experts that are online today. After that, we're going to look at what is cutting. A quick look at how cutting discs are made. And then how do we choose the correct cutting disc for the job. Safety, of course, really important. And then we're going to go onto the practical side where we'll show you a bit of footage of discs doing the job. And at the very end, we're going to have a live questions and answers. Okay, so whilst you're watching the live stream today, if there's anything you want to know about cutting discs, pop your question on the chat. And for those watching live at the end of the live stream, we will hopefully try to answer any questions you have about what you've seen today. So please put your comments on the chat, and we'll get back to you at the end of the stream today. Okay, so before we get into the products we've got on the desk in front of us today, let's just have a quick PowerPoint session on exactly what was in the agenda. What are the discs? Oh no, sorry, it's who's presenting. Sorry, you're experts. It's me, Paul. I live in Cheshire in England. I'm an application engineer for MRO for the whole of Europe. Quite a few years in manufacturing, as you can see, and 20 of those years have been spent in abrasives. So quite a lot of time spent here at Saint-Gobain. So all good. And I hope we have on board today my esteemed colleague, Mr. Derek Vrink. Are you here, Derek?
Yes, I'm here.
Oh, good to hear from you, mate. How are you doing?
I'm doing very well, thanks.
Pleased to hear it, mate. Derek, would you like to introduce yourself?
Yes, so I'm Derek Vrink. I'm the product manager for cutting off and grinding discs in Europe, and I've been with Saint-Gobain since 20 years. Typically, most of these years I've spent in cutting and grinding and being with customers, being in the field, but also very much in touch with the production area and also with product development areas in cutting and grinding discs. So yeah, hopefully I can answer some questions and add to the topic.
Brilliant, thank you for that, Derek. Senior product manager. That means you're really old, right?
It looks old, right?
Sorry about that, mate. Okay, so as we say, we're just going to have a look at a quick PowerPoint and go through a few of the things we said on the agenda there, looking at what is a disc, how's it made, and typical application. So if we just go through that now, Derek, you could assist with that if you can, please. Okay, so cutting off, first of all, what is cutting off? And it's really simple. It's basically separating two pieces of material. Separating one piece of material into two. And it's really simple. The fact the abrasive disc is mounted on a fixed or portable machine, so one or the other. That disc is rotated at speed and will cut the material into two due to its abrasive nature. Where's it used, Derek? Everywhere, right?
Yes, it's everywhere. And if you say cutting, these discs. They separate material, of course. It's just like a saw blade, and this is also how they should be used. You should oscillate the disc in the material to make sure that you always touch the smallest piece of material, as you would with a saw blade. the grains in the disc are more or less like the teeth of a saw blade, and this is how they should be used as well. And used, as you say, Paul, in all metal fabrication, a lot of general engineering, welding companies, but also, on the heavier side, foundry, rail, those kind of markets, you will find the more robust types of cutting discs.
Yeah. So, yeah, lots of different industries were used in. Okay, so I just thought it would be quite good to have a quick look at how discs are actually made as well. So, three main components to a cutting disc. Derek, do you want to take us through those, my friend?
Yes. So these days, still the aluminum oxide discs are the most popular one. This is just pure aluminum oxide type of grain.
Why would they be more popular than the others, Derek?
Well, this has got to do with the application on all types of steel. Aluminum oxide will perform, right? It's got a general, it's very versatile in its usage. As well as you look at silicon carbide, you will not find it so much in cutting off discs these days, because we have a very good range of diamond blades as well within the Saint-Gobain ranges. So, and it's far easier to cut stone or abrasive materials with diamond blades than with the cutting off disc, which is resinoid bonded. Then if you take zirconia alumina, that is quite a very, very sharp and very, very hard type of grain that you would use wherever you don't mind scratches on the material or you want to cut really, really quickly.
A little bit more high performance than alumina, right?
It gives a lot of aggression to the disc, a little bit more hardness. So this is where you would find typically in highly industrial areas. And one grain type that is added since a few years is the ceramic grain. So the ceramic grain in cut-off discs is becoming more and more popular, and it really brings an extra efficiency to your cutting application. So that
especially on harder materials as well, Derek,
yes.
Right?
Yeah, you can figure that that the use of a ceramic grain will increase your effectiveness by 3 times. So a ceramic grain really gives a very big added value to your cutting disc. It's quicker and the life will be a lot longer. It needs a powerful machine though, but these discs are also very much on the industrial side of things, so you will find powerful machines overall.
Yeah.
And if you go if you go to the bonds, well, that is relatively simple. This is a bakelite type of bond, which melts during the production process, and
so
it melts
thermosetting bond, right?
Yeah, it's more or less the glue that glues all the grains together into the shape, and it also makes sure that this bond actually works as the keeping the grain in the disc as long as it can. So as long as it is efficient and cutting, it will stick in the bond. As soon as it's worn out and it's broken to the smallest piece, it will break out of the bond. And it's a very let's say it's more or less a balancing act, I would say, to put the right amount of bond in the right disc
to give life and performance as well, right?
Yes, yeah. Exactly. Yeah. And then you have reinforcements. Reinforcements are there purely for safety. They don't cut, they don't grind. In this case, in this picture, you will see three layers of reinforcement. Glass fiber. In any cutting disc, you would find two on the outside, and in the middle there will be abrasive grain. And it's purely safety. So it's not only based on how much side pressure can a disc have, right, before it starts to break, but also based on the RPMs of the machine. A 125 disc has 12,250.
Yeah, it's basically 80 meters per second. The disc is traveling on the periphery, which is pretty quick. I mean, we do have non-reinforced cutting blades available, but they have to be in a fully enclosed machine, correct, Eric?
Exactly. Yeah. As soon as there's no chance of side pressure and the RPMs are relatively low, you can also lower the amount of reinforcement. Our discs are always reinforced so much that they can stand double the amount of rotations given by the tolerance, which is in the EN 12413.
Yeah, we'll go into that a little bit later on, the EN and the OSA regulations for that apply to these discs. And there are a couple of different figurations for cutting. There's type 41, which you probably won't recognize the term type 41 probably, but that's the discs we mean that are flat, and a type 42, which is what we call a depressed center cutting disc. We'll go into them in a bit more detail, why we have depressed center cutting discs and flat cutting discs. It's simpler than you think. And then a lot of different diameters that are available in the list there, but that's not exhaustive. We do have all the diameters. So when you're choosing your cutting disc, there's a few factors you have to take into account. First of all, your machine size. So your machine size should always match the size of the cutting disc you're using. So if you've got a 115 or a 125 millimeter machine, it's always best to have that correct disc on that machine. So always match your size of your cutting disc to the machine you actually have. Machine power you were referring to earlier, Derek. We see machines in the market as low as 750 watt, which is quite low power, to be honest with you, up to machines nearly 2 kilowatts these days, which are becoming more and more frequently available, aren't they, Derek? I would say 2 years ago, you'd rarely see a 1900 watt machine, but now they're becoming pretty much commonplace in the market, right?
Correct. It's really, if any Norton product is, within Western Europe, you would find it as to be an industrial product. So it's not a typical product that you would, use in your kitchen or in the shed immediately.
In the kitchen? What, you're cutting your steak up with this, Derek?
I don't know. Yeah, maybe, or sprouts. I don't know. But
it's been done before on one of our videos. Please check out the YouTube channel. You'll be surprised what you can do with a cutting disc. But probably digress from that. We're talking about this, carrots and other vegetables. There are a lot of other materials we can cut with these discs, and that again will lead you on to what kind of products you choose for what kind of abrasive grain you choose to have in your disc. We've got inox in the market, or stainless steel, more commonly known as carbon steels, which I think is by far the biggest percentage of materials out there in the market. But then other products like aluminium, which is notoriously difficult to cut, grind, finish, whatever, because it's so sticky. Stone, plastics, many others. So, we have to produce products that are capable of giving you the best performance depending on what material you have. And it makes a big difference which disc you choose for that. Also, the shape of material. And again, we're going to be going through all these in a bit more details. The thickness and geometry has a big impact on one, the size of the disc you choose, but whether it be diameter or thickness. So we'll come into that a little bit later. Another one we have to deal with quite a lot is what do you actually want to do? Do you want to cut as fast as possible, or do you want the disc to give you the longest possible life? So that also is a big impact on your choice of disc. And last of all, operator skill. Okay. There's not a lot of training given out in the market to these products when people come into sites and factories to use these. Sometimes they're just given a couple of days and they're straight out there in the shop floor. So we have to build in a lot of safety into our products to compensate for this. And also on the flip side, there are a lot of experienced guys that really do know how to use these discs properly. Okay, so before we come to me on camera, we just need to talk about safety a little bit, which we also do when we come to me on camera afterwards. But you see a lot of pictograms here, your safety glasses, gloves, hearing protection. All of these pictograms are actually labeled on the abrasive product themselves. As you can see on the bottom right, we have a typical disc in front of us there, and all of the different safety precautions you should take are on the disc as well as in a leaflet that comes with our products too, to make sure you are using the correct PPE when you are using a cutting disc. One thing Derek was alluding to earlier was the EN regulation and OSA also. All of our cutting discs are regulated by OSA, which is the Organization for Safety of Abrasives. So you can be sure when you're using a product from Norton, it's tested and manufactured to the highest safety standards that are in the market.
Paul, if I may,
Yeah.
just in between, we got a question from somebody on the chat
Oh, yeah?
asking, how do I know which machine power is right for my job and what are the advantages of a high power machine? I think
Yeah.
that's a very good question. That's exactly the your application is as successful and influenced by three or four factors. Is the machine, the man, the material, and eventually your disk.
Yeah.
The machine is a very important part of your application, and you can say the higher the power of the machine, the less stops you will have. Also, the least reduction of RPMs you will see. And
So you get
a
the job done
cutting,
quicker. Yeah.
yeah, and a cutting disk works at its absolute best if it doesn't slow down on the machine, right? Because if it slows
Yeah.
down on the machine on the lower RPMs, you will see a lot more wheel wear. So it's in fact.
You'll also see a lot more burn as well, won't you, Derek? Because if it slows down on the machine, you're taking more time inside the material. Therefore, the thermal properties of the action of cutting will spread into the component, and you'll start to burn. So
Yes.
it also has an impact on the type of grain you choose as well, as we were alluding to earlier. If you've got a low power machine such as this tool here in front of me, this is a 800 watt machine, so relatively low power. You can tell the motor's very small. It's nice to use because I can hold it with one hand easily, but for that machine, there's no point to use a high performance product such as zirconia abrasive in there or a ceramic because it just won't do the job. You'd be sticking to aluminium oxide. Also, it's not a heavy duty machine. You wouldn't be grinding through huge swathes of material with that or cutting through great material with that. If you are doing, you need something like this. The 1.9 kilowatt make a huge difference.
You will
Yeah.
save by moving up from 800 watts to, let's say, 1700 watts. You will save a lot of discs that you would need to buy.
Yeah.
The disc would last longer. You would do your work quicker, and also you would be in a lot more comfort, to be honest, because your machine does not.
Yeah, it doesn't stall, and you're getting through the job quicker. Yeah.
Yeah.
So just going back to the safety side of things. So we had the pictograms there. So I want to show you what I would normally wear. So it says safety glasses, but I always prefer to wear a shield like this because when I have a mask on, which is also something you should have with the debris if you're not in a well ventilated area, I can steam up my glasses quite quickly. So I always prefer to have a safety screen on like that, much more comfortable. Also, a good pair of gloves, really essential when you're cutting to save any burns or sparks getting onto your hands. Decent flame retardant overalls, your safety shoes, of course, which I have on right now. And something I quite like to use, especially in the hot months, when in the summer, not that we get that many in the UK here, are these sort of leather sleeves that I can put on. So I could wear a t-shirt and I can protect my arms from any debris or hot sparks when I'm cutting or grinding for that matter. And an optional extra as well is if when you're actually cutting and you can't get away from the trail of sparks that are coming from the cutting process, is a leather apron like this. I know it looks like I'm ready to go and work in the local butchers, but this is a really good at deflecting the sparks and the heat away from your body if you can't get out of the way of the sparks trail. So good idea to have all these bits of PPE when you're using these kind of discs. One more thing that we always recommend here at Norton when you are cutting as well is a special safety guard that we can apply to the machine. So we have a cutting machine here. This is a battery machine. We can put on the disc, if I got the right size, onto here. So put the disc on there. But when you're actually doing the cutting before you start, there's an optional extra guard we can use. We can actually slide onto the machine. Now, simply clips into place like this. And then you're ready to go. So you put your blade in here and you got this extra guard on. So just in case there's ever any problems, there's no way that the disc, which is spinning in this direction, can come outwards. It's always going to go away from you as an operator. So it's going to really protect you. Difficult to see sometimes when you're actually doing the cut, but it is a lot more safe when you're using this extra clip-on guard, which are available from stores online. Okay, so that's a little bit more about safety. One of the other things you must do as well before you mount a disc onto your machine is have a look at it. Have a look at see if there's any damage on the disc. So have a look at the disc itself. If there's any cracks or bits missing from the periphery of the disc. don't use it. Just go and get yourself another disc. It's just not worth the risk of using a damaged disc. And one last thing as well, on the center ring, if we could just zoom in there, Martin, we have an expiry date on here as well. So we always stamp an expiry on our cutting discs because these do have a shelf life of about 3 years generally, due to the bond as it goes softer over time. So always have a look at your validity date on your disc to check it actually in date. Really important thing to remember before you start cutting. Okay, Derek. Anything else to add there?
Yeah, it's just it's also look if you mention the ring, some people would ask, does it matter if the ring is mounted towards the machine or towards the outer flange?
Yeah,
that does not matter at all. The disc has no direction like a diamond blade would have.
Yes, exactly
so
right.
You can actually mount it the way you please.
Which is a really nice. You bring me straight on to the next point, how to actually mount a disc on your machine, Derek. Thank you very much for that. So here we have the grinder here. Okay, so we take off the top flange. Okay, so we remove the top flange. We leave the bottom flange in place because that helps locate the disc in the right area. We put the disc on this way or that way. As Derek says, it just doesn't matter. It's really down to your preference. Personally, I prefer to go this way around because I can see what product I've got on the machine better. So if I'm using a disc to cut different materials, I can have a look at what have I got on there. It's the Quantum 3. I can do anything with that with this machine, so it's no problem. So then we put on the top flange, and always make sure you put this the right way around. As you can see on camera here, we've got a raised part on the flange there, and on the other side it's flat. So with a cutting disc, we always put this flat side and machine down. Okay, that means we'll clamp that properly. Okay, so now with the disc is on and it's ready to use. Also make sure you set your guard for cutting as well. So I would always put the guard a little bit more of an angle in here. It appears this machine is not hasn't been adjusted for a while. So that's got me at the right angle for cutting now as well. Okay, because when I cut, I'm going to be cutting down here and I don't want the guard to get in the way and be trapped by the material as well. Okay, so that's how to mount a disc onto your machine. Another big error that a lot of people make when they're using cutting discs is actually the material clamping, and this is where you could have a problem with your disc. So we can get a piece of material like this in the vise. I'll put it this way around. So we've got the material secured in the vise. You think so? So we're going to start cutting, and I want to cut over in this area here. Okay. Now this is not correct. I only want to remove a small amount of material from this tube here. But you can imagine all this length of material that's free and in the free air. When I'm starting to push through this with this cutting disc, I'm going to get a lot of vibration. I'm going to get a lot of movement in the flex of this material. And that's going to transfer into the disc, into me. So it doesn't make sense to cut like that because you'll ruin the periphery of the disc very quickly and wear the disc away quickly as well. So when you're just cutting a little bit off the end of a material like this, try and clamp it a little bit closer to the vise itself. Okay, so we've got that much more secure. Then there's going to be a lot less flex in that material, and you get a nice, clean, straight cut every time like that. Correct, Derek?
Yeah, that's right. It's a very, very common mistake, and also people do complain about it. Oh, look, the periphery is all it's all worn out, and you can see the reinforcement sticking out. That is typically where the wheel has been hitting the material because of this vibration. So it doesn't work to keep your workpiece under your foot and then start to cut on something.
We see that a lot. It's dreadful. Yeah. Really clamp your material. And again, if it escapes, it can be dangerous. So, these things are running at quite high speed. So we've done a bit of safety. We've done a few tips about how you should cut. So I'm a bit aware of the time. We've only got 6 minutes left on this live stream, so we better scoot on a little bit. Choosing the right disc. Okay, so as you can see on the desk in front of me here, if we just have it overhead, please, Martin. If you refer to Martin, that's Martin on production here today. So I'm not talking to my imaginary friend, but here on the desk in front of me, you can see these are all cutting disc, and all of these from here to here are 125 millimeter. You can see how much choice there is out there. So how do you decide which one to use for what you're going to do? Okay, so there's there's a few different influencing factors, as Derek was talking to you a little bit earlier about. And today we'll be covering material types, material shape, and also the geometry of the material. Okay, so really simple as that. Machine power as well is another one, which we talked about earlier on a little bit, but really the material type is one of the first and main things we should look at when we're choosing our cutting disc. So here we have a few different types of material. We have carbon steel here, we have stainless steel here, we have aluminium here. Okay, so the three main material groups. We also have a tile to represent sort of stone or ceramics. So lots of different types of material. So it makes a huge difference on the performance of what you're actually going to do. So for stainless steel, you always want something such as a ceramic, because it's not particularly harder than carbon steel, because there are some very hard carbon steels out there in the market. It's just a lot tougher to cut through. It really does. And also, you want to be quicker on stainless steel, because if you use a cutting disc on stainless steel that takes a long time to cut through, you will create a lot of thermal damage, which you do not want to do. So always ceramics for stainless. I feel for carbon steel, Derek, aluminium oxide is normally more suitable, right?
Yes,
Yeah.
That depends a little bit on what you expect of your application. So aluminum oxide, we have some very high performing aluminum oxides. There is some low type of aluminum oxide. Just depends on what you expect your disc to do in terms of life, in terms of speed, and also you would find these days quite a lot of ceramic discs to work on.
Yeah, they do also work well, because again, there's lots of grades of carbon steel as well. If we're looking at structural carbon steel, for example, it's much more difficult to cut than standard black carbon steel. So ceramics do well on there. But it's all about refreshing the disc in the cut. If you're using the wrong kind of abrasive grain for the material, you will not refresh the surface of the disc, because when you're cutting through, we want this disc to break down a little bit, not a lot, but a little bit, because we want to expose new grains inside there. And if the machine is not powerful enough, or the material is too soft, then you will not get the best out of the abrasive disc at all. So it's really, really important. And to make it very clear for you, what we actually do on the blotters of our disc is we actually put a pictogram on here to show you what kind of material this disc is suitable for. So we see this disc here, which is again a ceramic disc. This shows it's suitable for both carbon steels and also for inox or stainless steel. Okay, so it's clear on that disc it's capable of doing both their materials. Okay. Sorry, we're scooting on a little bit fast now, because I'm just aware of the time is running away from us quite quickly. So next we can look at material thickness. All right, that's again a very big impact on the thickness of the disc that you're going to choose. So say, for example, we've got materials such as this, so quite a thin piece of carbon steel. If I wanted to cut through that, then what disc size, what disc thickness should I use? So for this example, we'll stay on 125 millimeter or 5-inch to keep it simple. So on this material, it's relatively thin, about 1.2 millimeters in wall thickness, this steel, so nothing too big. So we've got a choice here. I can go 1 millimeter, I can go 1.3 millimeters, 1.6, 2.5. Which one? They will all do the job without a doubt, but which one's going to suit you more? It's only a small area, okay, so it's not a huge amount to cut through. So to be honest, for this, a 1 millimeter is going to be absolutely perfect. So I can take the 1 millimeter disc and cut through that extremely quickly. You know, there's not a huge amount of material to get through, and I'll buzz through that really quickly, because that's what we want from this. We've done a quick cut and away onto the next job, get this bit welded on the component, done. 1 mil, perfect for that kind of application, Derek, right?
Yeah, correct. That's and typically in this case, you would choose a quantum-free ceramic disc on a relatively powerful machine.
Yeah, like the 1.9 here.
Yeah, or 1700 watt, even 1500 watt. But you want to avoid bluing of your material if you want to weld it afterwards. And also what you want is to avoid after work, right? So rework the burrs, for instance. With a 1 millimeter, you will avoid burrs, you will avoid bluing, and you get the quickest cut.
Yeah.
Right. So this is, if you would use a 3 millimeter disc for this, you know, you would end up with just slightly.
It would do it, but it would take longer, and therefore you would start to burn. So this is fine. The 1 millimeter fine for a small piece of material, thin piece of material. But when you're on sort of thin material, but you've got a long section to do, 1 millimeter will be absolutely perfect for that also. But if you're not extremely skilled as an operator, you probably need a little bit more control, because when you've got a long cut to do, it's very easy to flex a 1 millimeter machine, a 1 millimeter blade, especially when you're leaning over and you're trying to cut a long length. So when you're cutting thin material and you want to try and maintain a straight cut, it's often better to go for a slightly thicker disc, such as a 1.3 or a 1.6. It will take you a little bit longer to get through, but it will ensure, due to the extra rigidity of the disc itself, you will keep as straight as possible with these extra discs. We've got a little bit of footage of that, which if we can run the VT now, Martin. So Derek, do you remember this over in Telford? Yeah, so this is me doing a cut on a long piece of steel. You see, I'm actually going to cut this in half. So I'm using a 1.3 millimeter here, just to make sure I keep the edge nice and straight. You could do this with a 1 mil, Derek, right?
Yeah, definitely. And you're doing everything right here. So you're at the right side of the machine. It's sometimes difficult to cut these types of materials because you're going to be in a strange position somehow. And you
this part's easier here, but when you start to lean over is when you're going to start to maybe hold the angle grinder differently and flex the blade in the cut a little bit. So just a little bit easier to use if you've got a slightly thicker blade.
Yeah, it works also very much. This 1.3 is a very good disc on round material, so on tube, for instance.
Yeah,
it has a slightly more body to it, and this is typically where ceramics work very well.
Yeah,
1.6 for robust material is quick and.
So robust material, when we're talking about robust, if we go and have a look at the vise here, so thin material we've covered. When you've got something much thicker as this material here, this is where we also need a bit more body in the thickness of the blade. So again, you can cut this with 1 millimeter, but by the time you got through that, you'll have worn a lot away from the periphery of your disc. So again, if you get a disc with a bit more body, in this case, I've got a 1.3 on here. You'll be able to do multiple cuts on this material without any issues. Also, Derek was talking about oscillating. You know, on thin material, no need really to do that because it's such a small contact area. You can go through that relatively easily. When you have thick material like this, it's good to be oscillating. So what Derek means by oscillating is moving the blade in the cut like this as we're cutting down. So instead of just sitting at the same area and pushing the blade through the material, we oscillate the disc over the material. All that does is actually reduce the contact area that the blade has inside the cut. Therefore, it keeps the pressure on the blade to wear down, and it also concentrates the pressure in one area. Therefore, you'll actually get through this material much quicker if you oscillate the machine inside the cut. Correct, Derek?
That's correct. Just imagine the saw blade, the movement you make with this, and that's exactly the same the same theory. Yeah.
It is the same difference entirely. Also, talking about geometry, when you have material such as this angle iron here, okay, so again, you know, it's carbon steel. It should be relatively easy to cut. But the difference with angle iron, as you can see, we've got two pieces of steel welded together at 90 degrees. We've got to cut through this in one go. If you use a cutting disc on this, we're going to have actually at some point 2 points of contact. So instead of just 1 point of contact, at some point we're going to have 2. So again, disc stability, if you have a slightly thicker disc, when you do that, it's a lot more comfortable to do and a lot more accurate to cut this kind of material with a disc that's a little bit thicker. It will just give you a little bit more support when you've got 2 points of contact. It's always good to go a little bit thicker than 1 mil. So 1.3, 1.6 is absolutely perfect for that. And again, of course, geometry. If you're trying to cut something as big as this with an angle grinder, there's very little point doing it with a 125 millimeter disc because you're not going to get very far through that material with this disc before you hit the flange of the machine. So if you're cutting something big like this and you want to do it in one cut, again, size of blades, always great to get yourself a bigger machine with a bigger blade such as this, and you'll get through that material in one cut, save you moving it around in the vise and turning it over. very hard to make your cut lines meet exactly where you started on the other side. So it's again, the disc diameter depends on the material that you've actually got to cut, the component you've got to cut. So yeah, we've got a little bit of footage on that. If Martin, you can run VT of Mr. Derek Vrink cutting a square tube. So again, 2 points of contact on here, not one. And you see the nice oscillation from Derek there. Perfect cut and very, very quick because he's got the right disc on the right machine for the right component. Just really quick, and you could see how easy that was to do, Derek, right?
Yeah, that's but it comes down to what you actually are saying. The combination of the man, the machine, the material, and the disc, when that fits together, and you got that sorted out, there's not much that can go wrong in your application. You just need to think about what you're going to do, and what your expectations are.
Yeah. One other thing I want to talk about quickly is the two different discs here. So we have the same product here, Derek, in 2.5 millimeters. This is the Norton Quantum 3. Fully ceramic grain. Here we have a Type 41, so a flat disc as we were talking about earlier. Here, a different one, Type 42, deep press center. So why have we got two different products? Same thickness, same abrasive, same bond. Why is one deep press center here, and why have we got a flat disc here? What's the reason for that, Derek? Which one?
Do exactly the same job. It has grown historically. So if people are requesting a Type 42 and I need a Type 42, Type 41 would do exactly the same job. Okay. There is one thing that is that might be in the benefit of a Type 42, and this is that the flange will fall into the hub actually. So if you would want to remove a nail from the wall, for instance, you can reach the nail closer than in comparison to a 41.
So as Derek says, you can see the flange is inside the actual deep press center part of the disc. So again, it's slightly raised, but it's a lot better than it would be if I used a flat cutting disc. So again, if I'm trying to part something off, something sticking out from the wall, I can get a lot closer to it than you would be able to with a flat, with a Type 41. So Type 42's still quite useful.
I must say the Type 42 and the Type 41 in 2.5, these are typically discs that are made for robust type of work. And many people, they mistake the 2.5 because it has a hub for a grinding disc. Any cutting disc is made for radial use. Please only use it on 90 degrees because they're not made
like
for
this. We don't grind with a cutting disc. Again, we only have two reinforcements inside just two reinforcements inside a cutting disc. Grinding discs, they're much thicker and they have three. Okay, that's how they withstand this kind of lateral force. So cutting discs always have on the periphery, and that's even put onto the disc label itself. You see the label here, the little machine on there, saying always cut at 90 degrees. Okay, so never grind with a cutting disc.
Even if it's just a very small removal of a small burr here or there, just try and stay away from it because it will go wrong at one point. And you can say, it always went well. At one point, it will go wrong.
Exactly. It's you buy the right product for the right application. A little bit more about materials, because again, I know we're running over quite a lot today, but we've got quite a bit to cover as normal. And there's lots of other materials out there, such as aluminium. And aluminium is very soft. If we tried to cut the aluminium with the quantum or a standard aluminium oxide disc, such as this one here, yes, it will do it. But what you'll find is you will clog the disc. The disc will be covered with aluminium on the outer periphery. So we do actually have in the range specific materials, specific cutting discs for aluminium. So this will resist clogging and break down a little bit more readily than a standard aluminium oxide cutting disc or a ceramic. Okay, so there's really no need to be using any more high performance products on there. So there are specific products for material groups such as aluminium. And also when we're talking about other materials like ceramics and stone, plastics, again, this is where the silicon carbide abrasive comes into its own. And this is what we put into our multi-material disc. Because this, again, look at the pictograms. It can do steel, it can do bricks, it can do iron, lots of different materials, ceramics, plastics. That's due to the fact we have a silicon carbide grain in here, which is a little bit sharper than aluminium oxide and ceramics, and able to cut through all these more sort of unusual materials. So again, whatever material you've got to cut, whatever machine you've got to use with this disc, whatever size you want, we have the answer for you here at Norton. Okay, guys, I'm very aware of time, so I just want to make a quick summary. So if you're using a disc on a machine for a cut-off application, have a look at the power of your machine. Have a look at the type of material you're trying to cut. Have a look at the diameter of the wheel. Is it correct for the geometry of the component? Your operator, is he experienced, etc. So there's all these different factors you should take into account when you're looking at a cutting application. And speak to us here at Norton if you need any help with advice on what disc suits what application. We're always here to help you. Derek, anything to add before we wrap up?
Yeah, well, just no, thank you very much for that, Paul. Is just one thing to add is this: with our discs are made with high performance aluminum oxide, high performance zirconia, or very high performing ceramic grains. You don't need to push this very hard through the material. The wheel will do the job by itself. Exactly. If you do the right thing, if you have the right material, the right machine, you don't need to push anything because you will just push the disc to bits.
Exactly.
If you do
and it's more comfortable for the operator. If I'm cutting lots of different materials every day, I don't want to be pushing. I want the disc to do the job. So if you have all the factors correct, you end up cutting like you saw in Derek's video earlier. Really nice and smooth, like it's a knife through butter, no effort required. Okay, thank you for that, Derek. Okay, so for all of you guys for watching us here today live, stick around for the Q&A, which is going to come after this short break. For those who are watching on YouTube, we'll see you next time at Norton Live Streams. Bye-bye.